So in the previous video, I solved the system of equations using the method of substitution. This time, I want to solve it using elimination. The idea of elimination is, instead of substituting, we just add equations together. So, for example, as I look at these two equations, I could, this first step I'm going to take is just for example. It's not necessarily a good idea, but with respect to equation 1, this expression equals 1. With respect to equation 2, this expression equals -4. If I add them together, -3 plus 5 is 2, and 2 plus an invisible 1 is 3, and 1 plus a -4 is -3. Now, this is a brand new equation. It came from these two equations, and it's not the same equation as these, but it is related to those. Now, the method of elimination is going to require a little more strategy. I just arbitrarily chose to add these together. But the thing to notice is that if I multiply equation 2, by the number -2, then my system now looks like this. That means that equation 1 is not changing at all, but left-hand side and right-hand side are both going to be multiplied by -2. So that's going to be -2 times the left-hand side and -2 times the right-hand side. That is to say, -2 times 5x1 plus x2 and -2 times -4. And so the second equation now becomes this: -10x1 and -2x2 equaling +8. Now, taking equation 1 and my modified equation 2, you can see my motivation to multiply by -2, and it's right here. Now when I add these two equations together, the x2 terms will cancel each other. And so, let's go ahead and do that. Adding equation 1 to my modified equation 2, I get a -3x1 plus -10x1. That adds up to -13x1. +2x2 plus -2x2 adds up to 0x2. We can just, don't even have to write that down. And 1 plus 8 equals 9. And so, from here I can see that x1 is equal to -9 thirteenths. Now, using the method of substitution, we reach the same conclusion, but through a very different method. Now, as we get further into linear algebra, I'm going to strongly recommend that you abandon the method of substitution and get used to using elimination. It's going to correspond very nicely with the ideas that we're going to be reaching soon enough. And to find x2, I could kind of do like I did before and find a formula for x2. So it's not uncommon that I might actually use a elimination in conjunction with substitution. So I could substitute back into either one of these two equations and then from there solve for x2. Or I could just go ahead and do elimination again. So let's just get a little more practice with elimination, since it's something that's relatively new for some people. So what I'm going to do now is, I want to eliminate x1 and x2. I'm sorry, x1 in the first equation and x1 in the second equation. And as it is, I have a -3 in front and a +5 in front. I'm going to go ahead and do it like this. I'm going to multiply equation 1 by 5, and I'm going to multiply equation 2 by 3. That would have the effect of making the first equation, the coefficient for the first equation be negative 15, and the coefficient for the second equation be positive 15, and I'll be all prepped to do the elimination. I'm going to do the next step in my head, but multiplying both sides of equation 1 by 5, I get negative 15x1, and again, multiplying by 5, I get plus 10x2 equaling 5. Likewise, multiplying equation 2 by the number 3, this 5 becomes a positive 15. Multiplying equation 2 by 3, this invisible 1 becomes a visible 3. And again, multiplying equation, the right-hand side of equation 2 by the number 3, we get negative 12. Adding these together, x1's cancel, I'm left with 13x2 equaling negative 7. Therefore, x2 is negative 7/13. And I reached the same conclusion I did by the method of substitution. So I recommend that even if you feel comfortable with solving systems of equations, try to force yourself to get used to the method of elimination.